Okay, today we are going to divide physical quantities into four types. Ratio. Ratio of two similar quantities. If we get the ratio of two similar quantities, then we will get those quantities. They will not have any magnitude and they will not have any direction. Such quantities which do not have any they do not have any unit, they do not have any direction, but they have only magnitude. Such quantities can be called as ratio. So ratio, no unit, they don't have unit, no direction, they don't have direction, they have magnitude. Such quantities which do not have unit, do not have direction, but they do have magnitude. Such quantities are called as ratio. Let us take an example. Relative density. Relative density is a ratio. It is a physical quantity. Which type of physical quantity? It is a ratio. It is a ratio of two similar quantities. Relative density can be found out as density of object divided by density of water at 4 degrees Celsius. So here you can see that being a density, they don't have the direction, and density of object, its unit will be kilogram per meter cube. Density of water, its unit is also kilogram per meter cube, and these two units will get cancelled. So the relative density will not have unit because their units got cancelled. Being a density, they don't have the direction, but they will have some value. You will get some value here, value of the ratio, and that means it has the magnitude. Such quantities are called as ratio. Now the second type are scalar quantities. Scalar quantities, they have unit. Their units do not get cancelled, they have unit, they have magnitude, but they do not have direction, no direction. No direction. Such quantities are called as scalars. They don't have any direction. Direction is not needed to express them. For example, let us take mass. Of course, mass will have unit. What will be its unit? Kilogram in MKS system. Kilogram. So it is having unit. It will have some magnitude. You may go to the shop and you may say, okay, give me 1 kilogram sugar, 2 kilogram sugar. So it will have unit, it has magnitude, it has unit, but it doesn't have direction, no direction. Mass is not having any direction. Likewise, time. Time is also a scalar quantity because time is having unit, second. It is having unit and it is having magnitude also. Time we can say 1 hour, 2 hours, 60 minutes, 30 seconds like this. But time is not having any direction. Direction is not needed to express the time. So such quantities, such physical quantities, they are called as scalar physical quantities. Then the third one, vectors. Vectors, they have unit, they have magnitude, and they have direction also. Such quantities are called as vectors. They have unit, they have magnitude, and they have direction also. For example, we say velocity. So velocity is suppose 40 km per hour. So kilometer per hour will be its unit. So it is having unit. Magnitude 60. See, we are saying 60 km per hour. So 60 is magnitude. It is having magnitude also. And direction. To express the velocity completely, to give a complete picture about the velocity of a bike or car, anything, you have to assign the direction. Okay, the bus is moving along the north direction or south direction or east or west or northeast or northwest. So you have to assign the direction. So velocity is having the direction also. Then only its complete sense can be understood. So that's why velocity is a vector quantity. If you don't assign the direction, then it is not a complete expression of the velocity. That's why velocity is known as a vector. Then force. Force is also a vector quantity. Suppose I am applying a force 10 Newton on this object. I am applying the force 10 Newton on this object. So this force is having unit Newton. It is having magnitude 10 and I have to give the direction, in which direction I am applying the force. Then only you can understand where the object will move. The motion of the object will depend on the direction of the force. Suppose if I apply the force in this direction, then the object will move in this direction. If I apply the force in this direction, then the effect will be observed in this direction. So assigning the direction is compulsory for the complete expression of the force, and that's why we say it has direction also, and that's why these are called as a vectors. Now something extra I will explain about the scalars and vectors. This scalar, the value of the scalar may be positive, may be negative. But this positive and negative value does not define its direction. It does not make it a vector. For example, work done. Work done. If the work is done on any system, like spring, anything, if work is done on the system, then for the system that work done is positive. If the work is done by the system, then the system loses energy and that work done is said to be negative. So value of work done may be positive, may be negative. Suppose you are applying the force on the spring and the spring is getting the potential energy. So you are doing the work on the spring. So that work done is positive for a spring system. Now the spring is getting released and then it is forcing some object to move. So here the spring is doing the work, but it loses the energy. So this work done is negative for the spring. So work done is positive, for work is done on the system. If work is done by the system, then it is negative. But work done is a scalar quantity, although it is having positive and negative value. Like just as an example, some amount is added in your account, then you write it as a plus. And when some amount is withdrawn from your account, then in the statement you will write minus. Does this plus and minus is making amount a vector quantity? No. So like this, it may be positive, it may be negative. Then this EMF. In the EMF also, in Kirchhoff's second law, you will come to know this. When we are moving in the direction of the current, then the EMF is taken as a negative. When we are moving in opposite direction, then it is taken as a positive. So EMF is taken negative and positive, but EMF is a scalar quantity. Now, coming to the vectors. So the scalars, the addition and subtraction of the scalar follows ordinary addition laws. But what is the condition for vectors? Condition for vector is their addition cannot be dealt with ordinary addition of like 2 plus 2, 4. Ordinary laws of additions. It has to follow the vector algebra, vector law of algebra, vector law of additions. So if the quantity is having the unit, having the magnitude, and if direction is also assigned, but if it is not obeying vector's law of additions, then that quantity is not a vector quantity. Like an example of electric current. Electric current is having a unit ampere. We say 5 ampere, then it is having magnitude also. And we assign the direction of the current also. In all the circuits, you will assign the direction of the current. Without the direction of the current, the circuit will be incomplete. So you are assigning the direction also. But the current is not a vector quantity. It is a scalar. Although it has unit, it has magnitude, it has direction. But then also it is a scalar. Because the vector law is not obeyed in the current. Vector law is not obeyed in the addition of the current. When you are adding the current, the vector law is not obeyed. And that's why we will say current is not a vector quantity. And then the fourth one is tensors. Tensors, this type of this is not included in the syllabus up to the 12th level. It is studied in the higher levels, tensors. But in connection with this, I am giving simple its definition. So tensors are little bit complicated to understand quantities. They have unit, they have magnitude, they have direction, but after these three also, the clear picture is not clear. The picture will be not clear. Although you assign the unit, magnitude and direction, then also it is difficult to understand them fully. Such quantities are known as tensors. For example of the tensor is moment of inertia. moment of inertia. Symbol is I. If it is the axis of rotation, this is the body of mass m. It is revolving around this with the radius r. Then moment of inertia I is equal to mr square. Mass into this distance square. So this quantity, it is having the direction, unit, magnitude, everything. Then also, what is actually the moment of inertia? That concept will not be clear by this theory also. And that's why such quantities are known as a tensors. And no need to worry more about the tensors. That is not included in your syllabus.